Hello everyone, this is Hoda Ganji and today we are going to work on advanced walls. By the end of today we are going to create this wall and you should be able to assign all the R values correctly. To access this wall you can go to the Canadian Wood Council Effective R Calculator website. If you go to the search for walls, you can select your wall. In this case we are going with a wood siding, at least 20 millimeter of exterior air cavity which is going to be vented, half an inch plywood sheathing, 2 inches mineral wool. We are going for 2 by 6 wood studs every 24 inches center to center with R24 glass fiber batt insulation between the wood studs and a polyethylene for the interior vapor barrier. This should be okay. If I go to count assemblies, there is only one. I can go to search assemblies, wall ID 4434, and we are going to create this wall. You see we have about 11 layers going from exterior air film to interior air film. The two air films on the two sides are not actual part of the wall, but it's actually the air around the wall which can increase the amount of thermal resistance. Then we have the wood siding and a little bit of airspace, and because this airspace is vented, neither the airspace nor the wood siding would be considered in the calculations of the R value. That's why you see 0 is assigned to both of them. Then we have layer number 4, which is rock fiber semi-rigid board, this one. Then we have house wrap and plywood sheathing, which is number 6. And then we have the actual wood studs filled with batt insulation every 2 feet. Then we have polyethylene, the interior vapor barrier, and then finally we have the paint. So let's see how we can create this wall correctly in Revit in a way that we can have the R values. I want to start a new project. I'm going to use a default metric template, or you can go with architectural template. It's always a good idea to check your units. Type UN. The units for length is set to millimeters, the area on square meters. That's good. I want to change this to 1 decimal place after millimeter because we are going to work with details of the wall. Okay. I'm going to the wall tab, architectural, edit type, duplicate, and this is going to be my wall number 4434. That number comes from here, wall ID. Okay. You need to go to the edit tab so you have access to the layers. So we have the framing. Above the framing we have 1 layer of plywood. I'm going to ignore the house wrap, and then there is rock fiber, so it's going to be the second layer. 3 is going to be the airspace. 4 is going to be wood siding and exterior air film. So I'm going to create 5 layers on the exterior side of the 2 by 6 framing. How about I insert 1 layer, move it up, 1, 2, 3, 4, 5. All these 5 layers are going to be finished too. As you see here, this side is the exterior side and this side is the interior side. Okay, and whatever you do here is going to reflect in this information here. So for now the wall thickness is 200, that comes from there. We need to assign the materials and the thickness one by one. If we start from exterior, we have one air film. Okay, I can go to material, I can assign air, and this is an air film. That's good. It has already some thermal properties inside. That's good. Okay, I'll go with like 0.75 because I need this resistance to be 0.03, and I checked and it seems that like about 0.75 millimeters would create that amount of resistance. That 0.03 comes from this. Okay, let's continue with the wood siding, beveled. I would like to go here. How about I create a new material, rename it as wood siding. Over there, I'm gonna type wood siding. We have different wood shingles. I can go to siding and we have beveled siding here. Just double click, close this, and the material is assigned. You can also change the graphics to be more like wood. Okay, notice that this material does not have any thermal properties, so it's not going to affect the total value of the R resistance, so it's all good. Okay, I'm going to consider like 20 millimeters or 2 centimeters for this, or if you think it's not enough, you can go with 3 centimeters. And you see this value did not affect the thermal resistance because in that material we had no thermal properties. Okay, layer number 3, it's 20 millimeters or more of airspace, which is vented, so it's going to be 0. How about I go here? I'm going to use air, but this time I'm going with air openings because again this air opening material has no thermal properties, so it's not going to affect the total R value, so we are doing okay. The thickness is going to be 20 millimeters at least. It all seems good. Layer number 4, rock fiber semi-rigid board. You can also check it in the website. Okay, if you want to download this file, you can scroll all the way down and download the PDF file. So rock fiber, I want to go here, this one, and I want to just create a new material, rename it as rock fiber, go to the asset browser, I'm gonna type fiber here. There's one material named as jute fiber, so if I'm correct. I'm gonna select that one. It's one of the closest thing. And you see the thermal conductivity of this rock fiber is 0.067 watt over meters Kelvin. If we want to abide by this wall, we're gonna have the exact values. And if you are not sure about the thermal conductivity of some material, this is what you can do. Basically, if you remember from the building science, R value equals the thickness over thermal conductivity. So R equals D over K, and also K equals D over R. And RSI is thermal resistance in metric system, and K stands for thermal conductivity. So now that I have the R values, if I want to calculate the thermal conductivity, I can simply divide the thickness in meters by R value in metric system. So for instance, for this one, if I have 50.8 millimeters, which is 2 inches, it's going to be 0.0508 divided by 141. We're going to have this number for our thermal conductivity. So I can go here, rock fiber, and instead of this random number, I mean it's not random, but it's Revit default number, feel free to change that. Okay, and this is going to be 50.8 millimeters, which is 2 inches. Notice that although we are on metric template, if you type 2 inches, it's gonna automatically convert it into millimeters. Okay, layer number 5. I'm gonna skip that one and I'm gonna continue with the plywood sheeting for 1/2 inch. Okay, so how about I put 1/2 inch here, so 0.5 inch, 12.7, that's good. And I can go to the material tab, I can go with plywood sheeting, we have one over there. I can double check the thermal properties of this material. Thermal conductivity of the default plywood sheeting in Revit is 0.106. According to our table, we need 0.1155, so I'm going to go with this number instead. I'm going to copy and paste it here. It works well with 4 numbers after the digit for thermal conductivity. So 4 digits after the point. Okay. So that's that one. Plywood sheeting, and you see it's already added to the resistance. So far we should have 0.03 plus 1.41 plus 0.11, which seems about right. Okay. And now we get to the real structure. The structure in this wall, it's 2 by 6 stud, and that means the thickness is 6 inches and this side is 2 inches, filled by insulation. So I'm going to simplify this calculation here. We have wood stud and bad insulation every 24 inches center to center. So if I draw a schematic here, and if I go with a default number or an assumption of 100 inches for the height, which is about 2.5 meters, you're going to see that we have 24 by 2 stud over there, and 22 by 2 over there, and 22 by 2 over there, and then we have 100 inches by 1 by 1 plus 1. This is going to be the area of studs, and it's going to add up to 288 square inches. And if I divide it by the total area of this panel, which is 100 by 24, you see that 12% of this panel, each of the panels, 12% is made out of wood stud, and 0.88 or 88% is made out of insulation. So I want to come up with the equivalent for the thermal conductivity of the panel. If I go by 0.12 times the thermal conductivity of the wood stud, which is 0.126, plus 88% or 0.88 times the thermal conductivity of the insulation, which is 0.043, it's going to give me 0.053 for the watt over meter kelvins, which is thermal conductivity of the two studs and insulation combined. So the R value would be the thickness, which is 6 inches, which is 152 millimeters, which is 0.152 meters, divided by thermal conductivity, and that's 2.87. If we want to compare this number with this specification that we have, is kind of close. So the R calculator gives us 2.8. I came up with 2.87. Probably that difference is that I considered 100 inches as the hypothetical height of the panel, and that could be any other number. So based on what you consider as the height of the panel is gonna actually give you a different value. Okay, so if I want to follow exactly this same sheet that I have here, I can go with my own number, which is 0.053, or I can be more precise and follow the same procedure. If I divide 0.152, the thickness, by 2.8, the R value, you see that 0.053, which is pretty close to what we got for the thermal conductivity, is the actual equivalent thermal conductivity of the studs and the batt insulation together. Okay, so how about I go here, I'm gonna assign 6 inches, which is 152 millimeters. I can go here, and I want to create a new material. First, I want to create the material for the batt insulation. I can go here, I can type batt. Let's see what it brings. Glass fiber batt, that's good. Okay, I'm gonna close this. You see the thermal conductivity of the batt is very optimistic here, is 0.019, but usually the thermal conductivity of the fiberglass batting insulation is about 4 times that. So Revit is being too optimistic. Okay, I'm gonna leave this. Actually, I can go to graphics. I can change this to yellow to match the graphics that we have. The insulation is shown by yellow. And I can go with the actual number here for batt insulation just to have it for my own reference. Okay, so this is the batt insulation if we're gonna use that one, but I'm going to actually duplicate this material. I'm gonna rename it as batt insulation plus wood stud. I'm going to assign this value to the thermal conductivity to consider both insulation and the wood stud at the same time. Graphics is good, that is good, okay. That is added, and you see it's reflected in the total R value up there. So far we are good with the exterior side and the structure. And the other side, on the interior side, we have polyethylene. It's just vapor barrier. I might just ignore it because otherwise I need to assign 0 to that material, and Revit has kind of a problem with materials with no thickness. I'm going to continue with the gypsum board, finish, and the interior air film. So I'm going to need 3 layers on the interior side. So let's go here. Let me insert, move this new one down, insert and insert. So I have 3 layers below the main structure. This is going to be finish number 1 on the interior side, finish number 1, finish number 1. Okay, I can go with this layer, gypsum board, 12.7 millimeters or half an inch. So I can assign 0.5 and the inch sign, which is 12.7 millimeters to the thickness. Material, gypsum board, gypsum. For everything you need to double check the thermal properties, and you see this is 0.65, the thermal conductivity of the gypsum wall board. I just want to double check it. I have 0.1588 for the gypsum board, which is again a different number, so I'm gonna go with the CWCR calculator value for this one as well. Okay, this seems more reasonable. Let's continue. We have one paint layer. I want to go with paint. If you type just paint here, see what brings. Clad white, and it has no thermal properties, so it's not going to affect the total R value, so we are good. Okay, how about I go with like 2 centimeters, 20 millimeters, or if you think it's too much, we can go with 1 centimeter for the paint. Finally, we have the interior air film. Okay, and I'm gonna assign air again. You see it has thermal properties. Okay, you see the air on the exterior side had an RSI of 0.03, on this side is 0.12, which is 4 times more than that one. So if I assigned 0.75 to this one and it was okay, I can assign 4 times of that, which is 3 millimeters, to the air on this side. And now you see the total R value of this wall is 4.55. I can double check that. 4.55. Okay, you see we are a little bit off by 0.009. That difference could be because of the maybe the air resistance. Probably that might be because of the air resistance. Okay, it seems okay. I'm gonna say okay, but it's gonna probably show me an error because, as I mentioned, Revit has problems with receiving a number less than 1 millimeter. If you go with like 12.7, that's okay. But if you go with like 0.7 or 0.8, it's not okay. So we're gonna check. I'll say okay, and it's telling me layer number 1, which is that finish, has a 0 thickness. So below 1 millimeter, it's not gonna accept it. So I'm gonna put this on 1 instead of 0.75 millimeters. And in order to keep consistent with the R resistance for the air on the other side, I'm gonna reduce the value here maybe to 2.8 or 2.7. Let me see how 2.6 works. 4.55 and 4.55, 2.6 seems to work the best. Okay, so it seems about right. The thicknesses are correct. It's all good. The total thickness of the wall is about 30 centimeters, which is very reasonable. Okay, and you can scroll down. You can assign a type mark. This is going to be an exterior wall, 4434. That's the ID. Okay, I'm gonna put it here. We can see that in different views. Okay, and if I change the details to fine, you're gonna see all the layers, and you can get the thickness of the wall. Hit tab to select the right edge is 292.2. You can go to units, UN. You can change the rounding to 0 decimal places because it's too hard to measure a value lower than 1 millimeter on field. So let's go with 292. Also, if you go to annotate, tag by category, I can tag this wall. That tag, as you can imagine, it comes from here, edit type. Excuse me, you need to select the wall, go to edit type. The same type mark that you assign to the wall is going to show in the tag, and you can also change the size of the tag, so it's going to cover the whole name over there. So this is our wall, and if I go to view schedules and I get the wall schedule, right? I want to see the type mark. In my schedule, I would like to see the thermal resistance, the R value. You can add heat transfer coefficient or U value. I would like to know the width, maybe the area, and maybe the volume of the wall. This seems okay. I can say okay. So you see I have one wall in this file. The thermal resistance is 4.55. and you have the width, the area, and the volume of that wall. Okay. So now this wall is correct. So you know that whatever wall you use, which is the same type, is gonna have correct information for the thermal properties. So if you go to wall, architectural wall, that wall is now there, and you can always come back and use it. So in the next video, I'm going to show you how we can work with the graphics to show the layers of the wall as well as the studs and everything. So this wall works well with the thermal resistance and everything, but the graphics is not as good as we have here in this file. So that's what we are going to do in the next video.